Hi everybody and welcome to this lesson, which is going to look at some problem solving skills. And in this lesson we're still concentrating on questions around experimental design, and we're going to take a look at how you draw a conclusion and also look at control experiments. So what we're going to take a look at first is how we write a conclusion. Now, a conclusion is a statement that will identify what has been learned from the experiment. Your conclusion should always be related to the aim of your investigation, and it should use wording from the aim of the investigation. Now, if you remember, your aim is that question that you set off with at the beginning of your investigation. Your whole experiment is designed to answer that particular question. And whenever you're asked to write a conclusion, you should always, first of all, within the question, find the aim. And remember, it will be within the stem of the question. So in that main body of text at the beginning that introduces the question to you. So what we'll do is we'll take a look at this question as an example. So we've got here an investigation was carried out to compare the rate of metabolism in a species of cricket at different temperatures. 5 crickets were placed in a sealed flask which was fitted with a carbon dioxide sensor as shown in the diagram below. The flask was placed in a water bath at 5 degrees C and left for 10 minutes. The carbon dioxide produced per minute was then measured. This procedure was repeated at 10, 15, 20 and 30 degrees C. The results are shown in the table below. And you've been asked to draw a conclusion from these results. Now remember what I said, your conclusion should be answering the aim and it should use words from the aim. So your first job when you've got a question like this is to identify the aim of the question. So if we have a little look through, we can see it's right there at the very beginning of the question. We're looking at how the rate of metabolism is affected at different temperatures. So that is the aim of the question. Now, we need to answer that. Well, how does temperature affect the rate of metabolism in the species of cricket? Now, there will be a tendency for students to answer it like this and say, oh, as the temperature increases, the rate of carbon dioxide production increases. Now, that would be incorrect. And I know why that student will have put that, okay, because they're looking at these results down here, and we can see that as the temperature increases from 5 degrees C to 30 degrees C, the rate of carbon dioxide production does increase as well. However, we're not being asked to draw a conclusion using the results, okay? We need to interpret those results to then answer the aim. So we're not interested in how temperature affects the rate of carbon dioxide production here. We're interested in how it affects the rate of metabolism. Remember, there is a difference between your dependent variable, which you find within the aim, and it's what the independent variable is having an effect on, and then how you measure that dependent variable. So here, our independent variable is temperature. Our dependent variable is metabolism, and how we're measuring that dependent variable is we're looking at the rate of carbon dioxide production, because obviously it's a waste product in respiration. So don't be tempted to, write a statement into, just describing the results. You must make sure that you're answering the aim. What we're looking for is a statement that's like this. As the temperature increases, the cricket's metabolism is increasing. So you can see there, I have answered that aim and I've used words from that aim. So that would be correct. Now, some students might do both. They might say, well, as the temperature increases, the rate of carbon dioxide production increases, which means that the rate of metabolism in the cricket is also increasing. And that's absolutely fine because they have also answered the aim. Okay, they've used wording from the aim and they've just added in the results there as well, which is perfectly acceptable. So always make sure that in a drawing conclusion question, that you identify the aim first, and then you make sure you answer the aim and you use the words from the aim. Okay, so don't be tempted to use how they've measured the dependent variable in your answer. And just to prove that, I have put the mark scheme here on the page so you can see the correct answers there on the left, what the examiner is looking for. As the temperature is increasing, the rate of metabolism is also increasing. And you need that for 1 mark. You'll see on the right hand side what are not acceptable answers. So you can see at the top there, the examiner is not going to accept if you talk about how temperature affects the carbon dioxide production or respiration alone, because that's not what we're interested in. We're not interested in the carbon dioxide production. We're using that as a measure to inform us about metabolism. So remember what I said, you could use that statement as long as you also talked about metabolism as well, but on its own it's not going to be acceptable. And then at the bottom as well, quite clearly, you can't say as metabolism increases, the temperature decreases, because the results don't even show that. So the next skill that we're going to look at is a control experiment. Now these can be part of an experimental setup. So what we need to do is we need to recap the main features of experimental design. So remember that within a science investigation, your scientist wants to ensure that only one variable is affecting the outcome. And remember, the one variable that we are changing, that's our independent variable, and the outcome is our dependent variable. And there will be some way of measuring that. A scientist might actually set up a control experiment within the investigation. Now, the reason they might want to do that is to eliminate any levels of uncertainty. So it's to make sure that we know that it's the independent variable that's having an impact on the outcome and nothing else. And the whole point of a control experiment is it establishes like a baseline that your results can be compared to and allows us to see with less certainty that it's the independent variable that's affecting the outcome on its own, if that is the case. So what we're going to do is we are going to look at this example question here. I've chosen the same question that we looked at when we were looking at writing conclusions. So if you remember, we've got an investigation here where we're looking at how temperature affects metabolism in a species of cricket, and the way that we've measured that metabolism is we've looked at the rate of CO2 production in the crickets. Now what we're going to look at first of all is this very first question, so the first half of it. It's worth 1 mark. So the first half of the question, you've got to describe a control experiment, and secondly you're going to explain its purpose, but I want to focus on that describe the control experiment first of all. Now when you are asked to describe a control, you've got to first of all look at the question and think about what is causing the outcome. Now here the outcome is metabolism, and the way that we're measuring the metabolism is the rate of carbon dioxide production. What is causing that carbon dioxide to be produced are the crickets. But how do we actually know that it's the crickets producing the carbon dioxide? Now you might think I'm completely mad because you're like, well, of course it's the crickets producing the carbon dioxide. They're respiring and they give off carbon dioxide. However, how do we know that when we heat that rubber stopper or that glass that's in the water bath, that some material within those objects doesn't degrade and produce carbon dioxide? We don't. It's a massive assumption. And we'd look awfully silly if we went and presented our results, and in fact actually it's not, the carbon dioxide is not due to the crickets respiring, but it's actually down to the degradation of some material within our experimental setup. So we can't make that assumption. We have to make sure that we've got an experiment set up that shows that it's the crickets that are producing the carbon dioxide and not anything else. So that's what a control is. It's an experiment set up that is going to some way show what is causing the outcome is what we've put in the experiment and nothing else. So this first question is asking you, well, what setup, or what should that experiment look like that's going to show us that it's the crickets causing the production of carbon dioxide and nothing else? And you might think, well, that's very straightforward. What we'll do is just get rid of the crickets. However, you will not get the mark point if you just say remove the item that is causing the outcome. You must also make sure that you make it clear that everything else in the experiment needs to be set up exactly the same, because remember, we don't want to alter any variables that could also affect the outcome. So your answer should be keep the experimental setup or the investigation exactly the same and remove the crickets, or keep the experimental setup exactly the same and replace the crickets with dead crickets, because they're certainly not going to produce carbon dioxide. Or it could be keep the experimental setup exactly the same and replace the crickets with something inert like glass beads. But always remember to put down both statements. And I'll show you that here in this mark scheme. So you can see here it's worth 1 mark. I know it says 2 in that column, but we haven't looked at the second half of this question. But for the first mark, you'll see that you need to say the description, so the same setup, the same experiment, and with no crickets, or with dead crickets, or with glass beads. And you'll see in the right hand side, the examiner will not accept it ever if you're answering a control experiment question if you just say remove the factor that is causing the outcome. So you can't just say remove the crickets. You must also say keep the experiment exactly the same, or a description of it. You might go to the extent of going set up a glass flask with a rubber stopper and a CO2 sensor in a water bath, but remove the crickets. Now, the second half of this question that we're going to look at is why? Why are we doing this? And I have gone into this in a little bit of detail on that previous page, but we'll have a little look at it again. So remember, why are we, why are we removing the crickets? And remember here, we're removing the crickets to show that it's the crickets that are producing the carbon dioxide. Now, don't get into a habit of just going, oh, control experiments to show that it's the independent variable that's having the effect and nothing else. You need to make sure that your answer is specific to the experiment that's being set up. And again, I'll show you the mark scheme just to illustrate this. So here we have the mark scheme for your explanation. So it's just this little bit that's here. So you see, you'll get the mark if you're saying, why are we setting up this control? It's to show that it's the crickets that are respiring, or it's the crickets that are producing the carbon dioxide, or it's the crickets that are metabolizing, and not, the breakdown of material within the flask or the rubber stopper or something else. Or you're saying, without the crickets, there wouldn't be any carbon dioxide production, there wouldn't be any metabolism. That is also an acceptable answer because it's just the converse of that first statement. Now you'll notice at the other side there what we're not accepting. So don't just say, oh, it's to allow a comparison. That's not specific enough. And also don't just, again, give a vague answer where we're saying, oh, it's to show that the independent variables causing the results and nothing else. Okay, you need to make sure that your answer is specific to the question that's being asked. So I hope you found that helpful, and same as usual, what I've done is I've put a Google form together which has some example questions on how to write conclusions and also how to design control experiments and why we have control experiments within scientific investigations. So have a practice of those, and good luck.